part 2 of a video series on linearity, linear functions, what makes a function linear. And we've covered the idea of proportionality, about change, and linear relationships which have a constant rate of change, a CROC. So the idea here is this. We're going to investigate to see if there's a proportional relationship between the changes in the quantities. And if there is, then we can then claim that the two quantities create a linear relationship. So in this case, we found that there's a constant rate of change of 1/2. 6 times a half is 3. 2 times a half is 1. 6 times a half is 3. We found a constant rate of change between the changes in x and the changes in y. And what that means is the actual data, x and y, form this linear relationship. What we're going to do in this video is explore how can we use this information, and particularly this information, to help us produce or predict new y values. So for example, what if I wanted to know what happens to y when x is 14? Now if you're wondering where I get 14 from, I just am giving you an example. What if x was 14? Well, 10 to 14, that's a change of 4. If you change x by 4, and we follow our constant rate of change, then I can figure out how y is going to change. So 4 times a half would be 2, so the change in y would be 2. You can see that over here. If I went from 10 to 14, then x changes by 4, the change in x is 4, times a half would give you the change in y, which is 2. 4 times a half is 2. Now this is just delta y, the change in y. It tells me by how much y changes. So look, y used to be 7. It's now going to change by 2 to produce a 9. So what I'm able to claim then is if x was to go to 14, then we can say with certainty that y is going to go to 9. And we can see that on the graph. I know I'm going to go off the screen here, but 14 and 9 is going to keep us right on that linear relationship. Now we can do this kind of prediction for anything. Suppose you wanted to go to, I don't know, -3. Suppose you wanted to go back to -3 for some reason. Now another thing that is important to see here is you don't have to go in any particular order. Suppose, I don't know why, this is just to make a point, give you an example. Suppose you wanted to look at the change from 2 to -3. So 2 to -3, do you see a number line? On your number line you're at 2. You have to go back 2 spaces to get to 0. And then 3 more spaces to get to -3. So from 2 to -3, that's a change of -5. Now, when x changes by -5, and by the way, negative because if you go from 2 to -3, x is decreasing in value. So we're going from 2 to -3, that's a change of -5. So if you change x by -5, multiply by a half, you'll figure out the change in y. -5 times a half, if you want to grab a calculator, feel free, but that's -2.5 or -5 halves. And I just want you to be comfortable with either one. -5 halves, -2.5 are the same thing. Now remember, this just tells me the corresponding change in y. So if x changes by -5, then y is going to change by -2.5. Now remember, I'm changing from 2 to -3, so I want to see how y is going to correspondingly change. And what this tells me is that y is going to change. It's going to get -2.5. So a change of -2.5, that is, y is going to decrease by -2.5. It was at 3. We're going to decrease it by -2.5. Let me draw that one on the number line. Y was at 3, and we're going to decrease it by -2.5. Or decrease it by 2.5. So if I decrease by 1, 2.5. So 1 would take me to 2, take me down to 1, and then another half that would take me to just a half. So I'm now at 1/2. So if x is -3, y is a half. Now what I want you to do is just kind of think through how we do this. we kind of break this down into steps. First of all, we said, how does x change? Given that we know how x changes, we multiply by the crock, in this case the half, to get the change in y. Once we get the change in y, like -2.5, we have to add it to where we were, so to speak. Remember, I started at 2, 3, so 3 changes by -2.5 to get me to half. So in general, let's kind of break this down. Here's what we do first. First, we find the change in x. After we find the change in x, we multiply by a half so that we can find the change in y. Once we find the change in y, remember in this one, once we found out that y changed by 2, we were at 7. 7 plus 2 is 9. So we added that change in y in order to get the new y. So let me give you some symbolism here. This first y, I'm going to call it my reference. So if I'm at 7 and I change y by 2, I get to 9. So I'm going to call this y reference. So I was at 7, that's my reference value of y, and I'm going to increase it by 2 to get to the new value of 9. So I'm going to call it y new. Or I was at 3, that's my reference value, and I'm going to decrease it by 2.5 to get to a half. So my reference value was 3. I'm going to add that -2.5, or subtract 2.5, and I'm going to get my new y of a half. So in general, to get a new y, to predict a new y value, we're going to figure out what the change in y. And the way we're going to figure out the change in y is we're going to take delta x times a half, and then we're going to add it to the new y. So let's put this all together. To get the new y value, we're going to take the reference y value. Let me put this first. We're going to add to the reference y value how much y changed by. Now, how do we figure out how y changes? Well, right here. The change in y is a half times delta x. So in our case, that change in y was found by taking half of delta x. So you kind of break down your steps. First, we're going to figure out how does y change by. Figure out how y changes by, we're going to figure out how much x changes by. Because we know that the relationship between the change in y and the change in x in this case is you multiply by a half. Once we know how much y changes by, we add it to that reference to see where the new y is going to be. Oh, just one more thing. Actually, two more things. But one more thing first. One more thing. How do you figure out delta x? How did we figure out that, say, from 2 to -3 was a -5? Or how did we figure out that from 10 to 14, let me put that back in there, was a +4? Look back at that and see. For instance, to get this +4, we said 14 minus 10. To get that this is -5, we took -3 minus 2. So what we did to get the change in x is we took our, shall I say, our new x value, and we subtracted our reference value. So for instance, I took, what if x is 14? So whatever x value I ask you to figure out, you're going to subtract something right before it. To figure out that -5, you're going to take whatever x value I give you, and you're going to subtract the one right before it. So shall I say, take the new x and subtract the reference x? So if I give you a new x of -3, you'll subtract the reference x of 2 to get that change of -5. Once you get the change of -5, you multiply it by a half to get the change in y. Once you get the change in y, you'll add it to that reference to get the new y value. And now just one more thing, and this is the last thing. The constant rate of change is not always going to be a half. Depending on your situation, you might have different constant rates of change. And so, in general, the new y value is always going to be found by taking your crock, multiplying it by the change in x, and to get the change in x, you're going to subtract your new x minus your reference x, and you're going to add that to your y reference. So let me break this down. Let's look at the formula and an example all at once so you can kind of see what's happening. Let me just clean up my mess so you can see it hopefully as clearly as possible. So the original data was given there in black. And let's just suppose we want to predict a new y value. Let's try something here. Suppose you want to predict when x is -1. So what you would do first is figure out how much x changes by. From 10 to -1, that's going to be a decrease for sure, because you have to go 10 down to 0 and then down one more. So it's going to be a decrease. X is decreasing from 10 to -1, and it's going to decrease by 11. Now you could figure that out, check it if you want. You can take -1 minus 10. -1 minus 10 is -11. Now when I do that, I'm really saying take x new minus x ref. So the first thing I'm going to do is take the new x value that I'm talking about, -1. Subtract the reference x value. I'm subtracting 10. By the way, you could have done that anywhere you want because there is a constant rate of change. So I subtracted -1 minus 10, I got -11. Now, once I get the -11, I want to figure out, if I'm going to figure out the new y, I need to see how much y changes by. We know that that crock is a half, so -11 times a half is going to get me the change in y. And -11 times a half of 11 is 5.5. Negative times a positive are negative, so it's going to be -5.5. So now I know the change in y. That's this right here. I took that change of -11, multiplied it by a half, got the change in y of -5.5. So I took my change in x, I multiplied it by the crock to get my change in y. Now once I have my change in y, remember this is just how y changes, it's not what y is. Y was 7, it changes by -5.5. So if y was 7, get a number line in your head. If y was 7 and it decreases by 5.5, where would you be? Well, to find out, you can just add those together. 7 plus -5.5. So you're going to add, next thing you're going to do is add those two together. So add your y reference, your given y value. And when you add 7 plus -5.5, you're going to get 1.5. Check it on your calculator if you need to. You're going to get 1.5, which is your new y value. So in general, we have here a linear function formula. We have a way to capture how you can, in any problem, predict a next y value.